panel 3 on emerging technologies in electric mobility, new EVs, megawatt scale charging, wireless and pantograph charging, battery swapping, V2G and green mobility. It is my great honor to invite chair for this session, Miss Sulaja Firoda Motwani, founder and CEO, Kinetic Energy. May I invite moderator for this session, Mr. R.K. Singh, Head Business Operations, EV Charging at TATA Power Company Limited. Welcome, sir. May I invite panelists for this session, Mr. Sushobhan Saha Roy, Regional Transportation Sector Lead, Hitachi Energy, Asia. Welcome, sir. May I invite Mr. Deepak Jain, Regional Head and Business Development, EV Charging, TATA Power Renewable Energy Limited. Welcome, sir. I would like to invite Mr. Paresh Patel, CEO and President of System Level Solutions. Welcome, sir. May I request Mr. Pramod Mishra, Assistant Vice President, Planning at BRPL. Welcome, sir. May I request Mr. Ashish Naidu, Founder and CEO, Blue Motive. Welcome, sir. May I invite Mr. Jaiprakash Singh, Project Manager, EcoG Germany. Welcome, sir. Now I am handing over the session to moderator to take forward this session for further discussions.
So, very good evening, ladies and gentlemen. We have very interesting discussion and very powerful panel today, and very interesting session. EV is a talk of the town, and again on the EV, it is an emerging technology, emerging trends, whether it's a two-wheeler, three-wheeler, megawatt charging, induction charging. So it is very, very interesting session. So if you see in a couple of years, like EV has grown multifold, not only in terms of numbers, but also in terms of technology. When we started initially, the charging rate was very, very low. Like for charging one unit, you need to spend 10 minutes, 20 minutes. Now the charging rate has come to such an extent that people are talking about 400 kilometer charge in 5 minutes. Recently there was a news that BYD has come up with a charging technology and battery which can charge about 400 kilometer in 5 minutes. And even in today's scenario, in Indian market conditions, we have many vehicles which are charging almost 10 to 15, 20 kilometers in a minute. So I think that the great technological advancement has already happened. So we'll take up that first, that what all has been happening in last couple of years. So I'll invite Mr. Sushobhan that please let us know that what all has been happening in EV ecosystem in past 2-3 years, and what you foresee next couple of years how EV industry is going to evolve.
Thank you. It is a nice question. Let me introduce myself. I am Sushobhan Saha Roy. I take care of transportation vertical for Hitachi Energy Asia. And the questions of EV. So, in past 2 sessions I was there, I was listening to various problem statements. First one was that the main topic of the session is smart energy versus smart mobility. So, a few sessions was previous sessions were talking about smart mobility, how we evolved in India as well as in other parts of the world. And the mobility has like totally transformed from initially diesel, then now we are talking about electric vehicle. But at the same time, you think of the smart energy, whether we are seeing the smart energy, because the energy generation scenario in India has also evolved. Now we have various mix of energy sources like wind, solar, hydro and conventional. And at the same time the load centers for mobility. So it is also changed now. Now we have electric vehicles, we have various variations of loads. So how to sync these two? So as Hitachi Energy, we believe in connecting these two smart ends, like our world of smart mobility, at the same time our world of smart energy. And coming to electric vehicle, so I would like to tell you one incident in 2013 when we first started a project, a very ambitious project in Switzerland. And today we call it a flash charging technology. So with the Genova project, where the customer statement was conventional buses or LRT, those were consisting of overhead catenary systems. So in Switzerland, although it was not pollution, but they were talking about visual pollutions. At the same time, maintainability of overhead catenary systems. So then we ran a pilot project with simulations, few goals in our mind. And the goals were like infrastructure will remain same. We need to connect with the smart energy system where there will be peak schedule. Like if this high charging infra requirement, they all start charging at the same hour. Then how we can handle the peak in the requirement of the infrastructure end. Like all discoms are talking about that we need to develop a huge infrastructure, but for a limited time frame of power supply. So those kind of challenges were addressed in all those projects, and we did a pilot there, and then the transport authority and the operator both were very convinced, and it was in pilot observation for 3 years. And in 2016, we got the first order of 12 articulated buses from the authority. So that's how the transportation in e-bus has evolved. The charging time for this flash technology varies from 20 seconds to 30 seconds. We are not talking about minutes. So charging infra requirement has drastically come out. Like when we are talking about in the first session that the requirement of battery storage. So that calls for huge infrastructure of battery maintenance and the lifetime. After the lifetime of those batteries, then it is cost and overall cost of the total ecosystem we need to think of. So initially, maybe we can think that it is a costlier technology, but if you see the overall ecosystem, the infrastructure requirement of grid requirement or discom requirement, that will come down drastically. So we talked about EV system for buses for 30 minutes charging time. 5 days, then we start talking about our flash technology can connect in 1 second, disconnect in 1 second, and charging system starts automatically. So if onboarding and disembarking, it is 20 seconds, and charge 17 seconds. That's how the cost of infrastructure is coming down for power. So, and we are connected with smart energy and smart energy.
So very good insight, Sushobhan. Now I request Paresh Patel to just give his insight at how we have been evolving in a couple of past years and how we foresee next 3 to 4 years.
Sure, thank you. Thank you everyone for being here. I think it's our last stretch, end of the day. And thank you, the panelists, for being here as well. What I wanted to do was say, in terms of system-level solutions, the spin-off is converting mobility, which makes EV chargers and makes other things that are related to EV. System-level solutions has been in smart metering attached to Finland, Sweden, UK, and we know how the metering side, the distribution side, and then the charging side, and effectively the microgrid side works. And so I wanted to talk to you a little bit about the future on what the trends are that I'm seeing. And BYD, the latest news that we're all talking about, has set a goal to say that, and I'm saying a goal, right? At megawatt charging at in 5 minutes. It's a goal because there's a huge complex ecosystem that needs to be traversed before we can realize that here in India. Right? From car manufacturers to electricity infrastructure to understanding the grid balancing, all the way down to grid balancing to generation. It goes up and down the food chain, so to speak. And we have to make sure that we're doing India-centric solutions that are based out of India and the needs of India, rather than looking at solutions that we see abroad, because the scenario for various things abroad is different. Our electricity grid and the way it's operating and how we do things here is different than in UK, in US, and other places. So we have to make sure that whatever solutions that we provide are based on what the Indian requirements and needs are. And so when I talk about EV charging and EV chargers that we've looked at and built, we have a line from 30 kilowatts to 240 kilowatts. And what we're seeing is, the average Indian car probably has, what, a 40 kilowatt battery, right? And so now, does it make, and so a 40 kilowatt battery, if you have a 60 kilowatt DC charger, will charge in about an hour, right? Maybe less than that if you're talking about 80% charge. So, and then the infrastructure needs to be there that basically allows you to bump up that and to go to 180 to 240 kilowatts and beyond. And so then we have to have our car manufacturers build out onboard chargers that can handle that amount of energy being delivered in that amount of time. Because the other I guess, key parameter that we have to look at is environment. India's environment is typically on the hotter side. And when we design our DC chargers, we see that the fans kick in very quickly, right? Because at 180 kilowatts, you're generating a lot of heat. And the ambient temperature is 43, 45 degrees Celsius. And the charger trips at 65, for safety reasons. And so, all these parameters have to be taken into account for the Indian scenario. And but the good news is that all of these chargers that are being built for a number of manufacturers have specifications, which were the earlier speakers have talked about. And I don't know, how many of you have heard of ISO 15118? Right? That is the overriding type of spec from the international community that covers V2G, that covers pantograph, that covers interoperability, that covers security, that covers high-level communication. So all of that is rolled into that spec. And what we're doing in the future is adding to that spec. We're building out the components, manufacturing those components as per that spec. So when you talk about, let's say, wireless charging is a part of this spec. Now again, whether India is ready for wireless charging is a different story, but I'll give you one example. When I was at Move America in Austin, Texas, and there's a company called Whitericity. And this company has wireless chargers starting from 3.3 kilowatts to 22 kilowatts. Now, because it uses basically magnetic resonance to do the charging, there's a efficiency level that's there, right? It's 90 to 93% efficient, okay? So you've got losses there. But then on top of that, they were boasting, maybe it wasn't a boast, I don't know what it was, but they retrofitted a Ford E-Mustang, and they talked about the problems that they have. The space, there's a box for the wireless thing because it's nothing but, bunch of inductive load it's pushing. And so the wires that were there, the amount, it took them 6 months to retrofit a Ford E-Mustang. And so the thing is, there are challenges to all of this stuff, and it's very easy for us as panelists and thing to say that, oh, this is what we can do. But when it hits ground reality, that's what we're looking to do. And in the next 3 years, I see, I'm pessimistically optimistic that India will make its baby steps by looking at what's happening in the world, applying it to our own needs, and moving forward in charging infrastructure. The good news is we're starting to see the discoms and the energy companies, one of the biggest pain points is the transformers and the lead time for transformers for putting these things, installation. That's all slowly changing because there's a momentum that's building. And it's which came first, the charger or the car? And that needs to be answered. And now as more cars come, more chargers come, or should more chargers be placed with cars? So, those are some of the things that India is looking to. There's a gradual improvement. And in the next 3 years, I definitely see a lot of need for various bus applications, fleet applications, and consumer applications.
So thank you, Paresh. I think very good insight on global developments and also that what is going to come in. Now I'll come to Jaiprakash Singh. You have been into the manufacturing industry for quite some time, and I would like to understand from you that what kind of technological advances have been happening in charging technology, charger technology, at component level, at power management level, and how do you see next 3-4 years, say by 2030, what kind of technology in terms of manufacturing and the charger technology going to come in India?
Okay, sir, thank you. Good afternoon, everyone. I am from EcoG Germany. Actually, EcoG is a developer of the charging systems. We are not the manufacturer of chargers. So EcoG is working only for the technology and helping OEMs to develop their product. So, if we talk about the future, we can look into the past also. When we started EV charger in India somewhere in 2016-17, we started somewhere with the 12 or 15 kilowatt of the BSES charger, BSES 001, with a voltage of 120 volt and the maximum current was 120 ampere. So the latest example we saw with the BYD. There was a small video clip was going on the channels. A simple calculation, 1000 ampere at 1000 volt. Result was 1 megawatt. So at this moment in India also we are having chargers up to 240, I think 360 kilowatt also installed in the field. But we are unable to utilize because of low voltage charging. Still less than 500 volt I will say this is the low voltage charging only. If I utilize 250 kilowatt or 150 kilowatt charger with the 400 volt at the same example for 100 ampere or 200 ampere current, and same charger if I am utilizing at 700, 800 volt, the power delivery, dispensing of the power will be double. So the time is direct related with the time of charge time. So in India, if I see about the cars, mostly we are talking about the passenger cars. We are not worried about the bus and the truck segment because they have almost overnight time, 8 to 10 hours to charge their heavy load. If we talk about the cars, then people are more worried about the time, charging time on the highways. So in India also we have the vehicle available with 700 to 800 volt, which can take 150 to 200 kilowatt of charge, kilowatt hours. Okay, so that I see the fast charging is available, but the problem what we are facing, the 250 kilowatt charger charging small vehicle is having the small voltage range like 300, 400 is underutilized, and the asset is laying at the sides but underutilized. So in future what we are looking actually multi-dispensing solutions. For example, is already there with the some Western countries and European countries, where the power modules are kept outside, backside, maybe 1 megawatt or maybe more than that capacity, and dispensers will be there on the front side. small dispensers with the variable load options, and the load management system will be sitting outside and on the top of that. And if I connect the 5 vehicles with a different capacity and a different demand, the load management system will be able to cater all 5 as per their request and as per their requirement. And this 1 megawatt my power converters will be fully utilized. Even whether the bus is charging with asking the rate of 250 or 300 kilowatt hour, another vehicle is asking rate of 330 kilowatt hour, the system will be able to give. Right now what is happening, my 240 kilowatt charger is engaged with one vehicle which is asking only 30 kilowatt. So 210 kilowatt power still is there, which charger can deliver, but demand is not there. And suddenly another vehicle comes to this charging station connected with the 100 kilowatt charger, but demand is asking 150 kilowatt. That is a time, it cannot get the full power, charging power. So if you talk about the multi-dispenser system with the power management and power blocks, the power units are sitting backside, so it can solve this problem. This is the one solution what we are looking in the future. In India, a lot of people are working on that also. Some units got installed in Bengaluru and Delhi, Gurgaon, but that was all imported units. I think 5 or 7 units across the India got installed with this arrangement, but all are imported from the Europe. In India, so far no one is manufacturing, but I see by this year end or by next year, couple of units will be there from the Indian manufacturers. This is, I see, in next 1.5 to 2 years. Okay, a lot of manufacturers will be there with these options. And further, after this will be the megawatt charging solution, where we will be talking about the more than the 1000 ampere of current, something around 2500 or 3000 ampere with the voltage of 1250 volt, up to 1250 volt. So this is going to be something around more than 3 megawatt system. So it can be single unit also or multiple dispensing unit also. Single unit we have the challenge with the cables. If the cable management is there and the vehicles are able to take in range of megawatt system, so industry can deliver this type of system. So here actually the case study, if you talk about the requirement, will come from the OEM side manufacturers, means vehicle OEMs. So in future if they ask charger manufacturer to deliver 1 megawatt, yes, they will be able to deliver. So power electronics side and the charger side, I don't see any limitation for the multi-dispensing unit, whether this pantograph or single unit having multiple megawatts, this 2-3 megawatt single unit system. I don't see the problem in technology. Thank you.
Thank you, Jaiprakash, for sharing your thoughts on charger technology. Now let's come back to power utility. So again, this is entire business is of power transition, and until unless our power discoms are ready to deliver this kind of energy which is going to happen, I'll tell you that the age of today, Tata Power alone in all our 4 verticals, home charging, public, fleet and bus charging, we are on an average delivering almost 300 plus million units annually. And so this is a story of only one charge point operators. And you are operating in Delhi, and there are a couple of bus depots have come of late in last 2-3 years. So how are you managing your power network? How are you planning for your future? I'm sure you must be having challenges not only in terms of power demand but also in terms of fluctuations and also in terms of harmonics induction. So how do you manage? How do you plan to manage in by 2030, when we would be touching 30% penetration in most of the sectors.
Yeah, thank you, Chair, and good evening, everyone. I would take it otherwise. It is not like challenge, it is kind of opportunity for us, because DISCOMs are already in the process of going to the next phase, evolving to the next phase. And in this evolution or transition phase, this becomes as an opportunity for us. Because if anyway we had to transition for the next level, we had to upgrade our system. If I take care of EV load or other upcoming load in this transition, that will add a lot of value for us, because take an example, if you could have transition 10 years back and the EV, such high quantum of EV load has come up now, then we had to rework again for the EV load and the cooking load and other loads, which new loads are coming up. So when the utility is already in the verge of transition, this kind of load will add value to us to have further foresighted planning. And if you take the example of Delhi, about 500 megawatt of load is coming up in next 2 to 3 years. 100 megawatt load is already live. That is only the EV part of bus. If you take other load, car and bike, it is another 300 megawatt more. And by 2030, it will be around 700 to 800 megawatt. So if you take that load into account, that is contributing to about 10% of Delhi's load. Presently, we are operating at 9,000 megawatt, and by 2030, it will be around 12 to 1300 megawatt. These transition or new load has given DISCOM opportunity to see how much network we have in that particular area, what is the kind of load is going to come in next 5 to 10 years, organize our network into different at different voltage level. You see, e-buses are like 4 megawatt to be minimum, and it is going up to 20 megawatt at one location. So my plan would be what kind of voltage I'll serve at one location 4 megawatt and similarly at 420 megawatt. I have seen in last 2-3 years practical implementation of e-bus charging infrastructure that estimation of load is generally on the lower side. People think, or the operator or the transport corporations are thinking, let us come with the minimum load so that I can start the operation. But it has to be considered that the network cannot be laid every next year or every third year or fifth year. We have to think a horizon in the mind. Like if we are talking of 240 kilowatt charger, or in the previous session it was 360 kilowatt, then 720 kilowatt, 1 megawatt. Every day the charger capacity is increasing, and matching that pace, it will be very difficult for DISCOM to lay the new kind of network until we have some horizon in the mind, at least 10 years horizon, I would say. So first thing is the planning has to be right. If you want to go 1 megawatt, fair enough, DISCOM is ready with that. Two major constraints comes into the picture. One is the space, because we need space to install our infrastructure, electrical infrastructure. In Delhi, up to 4 megawatt, you can go up to 11 kV system. But beyond 4 megawatt, you have to have 33 or 66 as the case may be. For power at 33 or 66, you have to have a step down at 66 by 11 or 33 by 0.4. For that, you need to get at least a space of 1500 square meter for a step down, and then for switching station for metering and others. So in a bus depot of say 10 megawatt, you have to spare at least 1500 to 1800 square meter of your space, which was otherwise being utilized to park the bus. So that space has to be considered while planning, and you have to make your mind that that space is going to reduce from your fleet parking station. Number two is the initial capital expenditure. So if you go for I would say conservative planning, then you will spend at 11 kV also, and then after 2-3 years you have to dismantle that 11 kV and lay the higher voltage system. So that will be the double cost to the utility or the applicants. So these, at least these two things if we keep in mind, it will facilitate the utility to go for the long-term planning. At the same time, it will be cost economic for the operator or the transport department. I have seen another particular thing that utility also have to come, like us, have to come forward to support this cause, because society is going through a change. So beyond the normal thinking of electrification or the planning, we have to think that what will suit our client or the transport department. For example, if we have to think of say 5 megawatt of load and creating a grid of say 45 to 50 crore, means step down from 66 to 11, then 11 to 0.4, that will create, like for 10 megawatt we have to spend around 60-70 crores, that comes about 7 crore per megawatt of load. That may not be viable for the operator or the corporation. So we have to think if we can interconnect at 11 kV and provide sustainable and reliable power to our client or the corporation. Last thing you mentioned, sir, about the THD, the harmonics. Today we are less than 1% or say 300-400 million unit at this stage, no problem. We have studied and we have seen that at load, when it is on full load charging, THD is not much of a problem. At voltage level, it is not a problem. Current also, it is much below than the limits. But when it comes to the no load, it goes, current harmonics is very high. So those are in initial phase. The quantum is very less, network is like working okay. But when it comes to the higher quantum, this may pose a problem. And as a planning engineer, I have to think normal design of the transformer, cables and other equipment, and think of aligning with the upcoming problem, or maybe some kind of filter at the load level so that the pollution does not come to my network.
So thank you, Pramod. I am happy that DISCOMs are well prepared, and they also see the opportunity in getting the and more energy, more vehicle getting added. So primarily their role is to sell electricity, and they are getting that very good opportunity. So now I'll come back to Deepak. So Deepak is developing the charging infrastructure across north part of India. So Deepak, can you let us know that what kind of regulation or regulatory support has been in past 2-3 years, and what kind of regulatory or policy advocacy you would like to have in next couple of years to optimize the power cost and also to optimize the overall cost of operation of charge point operators, because as of today, if we see that most of the public charge point operators are not earning profit as of now because of very low penetration. So just take us through.
Sure. Thank you, sir. Good evening, everyone. So I may start with some like granular this thing. So when we divide as a charge operator business, there are largely 3 parts. One is the real estate, then there is upstream infra, and then there is a charging infrastructure. So these 3 parts bullet a complete charging network, and obviously the app part. So real estate is a big problem for CPO because the policies earlier and the current one are not supporting government land to CPOs directly. They are giving options to OMCs and PSUs, but not to the private CPOs. So that is the one concern which we are raising. And in their recent draft policies also, they have mentioned, but that is attached with the tendering process. And another thing is always a big cost for CPO, which is upstream infra. So upstream infra higher cost is a big bottleneck. So like we all know, maximum states have a subsidized electricity EV policy. So but still there are states where are having demand charges, fixed charges. which are killing, which are basically recurring charges. It is like a monthly rental for a CPU, and utilization is like 2-3%. It is good in urban areas, but when we are talking about states like Rajasthan or other states, where penetration is good but not in rural belts, where you have to pay demand charges, fixed charges. So we are always requesting government that they can consider. We are giving our representations also. On the regulation front, it has to be a uniform EV policy across. That is the requirement from CPOs. That is the sound given by in all conferences like this. And another one would be the land allocation, which has to be it has to be a same platform like they are giving to the OMCs and the government agencies. Why not it has to be given to the private CPOs so that they can sustain and they can run this business, because it is a capex intensive business, and realization is beyond imagination, because now the EV penetration is increasing, so it may be break even by 5 to 7 years. So I think on regulation front, government is supporting, state governments are also coming up, but still there are a few issues which are right now going on. But we are hopeful that in coming time it may resolve. Thank you.
So thank you, Deepak, for articulating the challenges faced by charge point operators in terms of power cost and also land acquisition, and also the feature requirement that which will facilitate the CPOs to deploy the charger on fast. So again, next time we come to Sushobhan, so now that a lot of technologies are happening in the megawatt charging, MCS is under discussion, under testing. So how do you see that MCS deployment in India? Say by 2030, can we have the MCS in place for passenger vehicles apart from the trucks and buses?
Okay, so as my previous speaker was telling that we need to adapt technology. Of course, technology is there throughout the world, but we need to see whether this is applicable in India, and we need to take baby steps. And we agree with it. And baby steps are already been taken. Like our present government, I talk about government, is very welcome electricity. I'll cite one example. Our Transport Minister, Mr. Gadkari, and he once attempted to travel in other parts of the world and saw Delhi. And he tried to go further and tried to investigate how it works and why other parts of the world are welcoming this in bus. And then he tried to brought that innovation in the Indianized version. And I'm again talking about the bus, first charging bus technology. Then he took the initiative with different government authorities, and if everything goes well, that technology, it will not be far, that it will be available in India. Now, how the present government is welcoming innovation, and that we are thinking of at the same time, the overall cost of ownership ultimately from taxpayers' money, right? So if we need to see that the money is well utilized, just because there is a lucrative technology somewhere, we should not adopt it. So the Indianized version of it, which requires the cost effectiveness of every penny spent for this project. And when we further investigate that how it can help us, the OPEX and CAPEX. So our speaker was talking about CAPEX. Now, if the medium voltage or 33 kV level charging comes into picture, that again a big infrastructure India has to build. But at the same time, if we think of innovative ideas like our present government is also trying to explore, that whether an opportunity or on the route, well, when on the route the infra is already available and there is no peak for few minutes also, few seconds. So whether that will be taken care by the existing infra. So if that can be handled or that can be taken by present infrastructure, then we don't need to invest too much in the infrastructure development. So if coming back to the again story, that if there is a route, the present pilot project is happening in India, if there is a route where on the go, when the bus moves along the route in both the direction, the on the route, if we can identify the 33 33 kV or 11 kV infra, which can fit the DC charger to the bus for few seconds. Few seconds means 20 or 30 seconds based on the scenarios and simulation. There are a lot of inputs from authorities as well as operators. And then the overall ecosystem of the spending of this taxpayers' money will be addressed. So it is not only the technology price, the upstream, downstream and OPEX. OPEX means it is easy to consider increase number of buses. But how? Like since morning 6 a.m. if the buses runs till evening or at late night also, then number of drivers will increase. And the salary of drivers are also part of OPEX. At the same time, energy cost. So if all the buses are getting charged at the depot, where you need to have huge charging infra in the depot, which will again incur a cost for the infrastructure. Whereas a fast DC charger at the entry and exit of the depot, without much renovation of the entire depot structure, without increasing the land, if you can do that, that is the cost efficient way of handling the situation. So the innovative ideas are there throughout the world, and at the same time our present government is welcoming those innovative ideas. So I think that will change the scenario 5 years down the line. It is not very far, that is my personal belief. Maybe this year itself we will see some pilots, and if it goes successful, the money is well spent and overall cost of the infrastructure, OPEX and CAPEX are well spent, then it will be the future of India.
Thank you, Sushobhan, for very good insight on megawatt charging. Now I'll come back to Paresh. So now we are talking about vehicle to grid, integrated with renewables, rooftop solar grid. There is a demo also here. I'm sure most of you must have seen there. So considering the large number of deployment of vehicles enabling vehicle to grid, how do you see that blockchain or AI/ML can play a vital role in implementation and facilitating a very simple, payment mechanism for the customers? Simple, like we have a QR code scanner, anytime, anywhere you can even pay to Sajiwala. So how fast we can see this in India?
Boy, that's a very big question, but I'll try to answer that. So vehicle to grid, again, what the cars that are in India, I don't know the statistics right now, how many vehicles in India have that vehicle to grid support, where the vehicle through the power line communication tells the charger and another piece of equipment that I have excess energy or I have energy to give back to the grid. So what will happen is
in R&D stages.
Yeah, right. It's at the very beginning stages, because the main thing is there's a cost associated with that, both in the car and outside the car. So what happens is that you're taking this DC and then you're reconverting it back to AC. It's almost like a PV inverter, right? And then it's being applied to the grid. Now, whether it's charged or free or you're paying to put back into the grid is a different story as well. But the thing is that vehicle to grid, the cars have to support it. Then the homeowner has to have the appropriate equipment that's installed there to basically make that transition. And then the meters and everything else downstream have to support that basically ability. So as I said, it's a very complex ecosystem that's there for doing a vehicle to grid solution. And one of the major challenges that we have is that, when the average price of a vehicle in India is maybe 8 lakh rupees, right? Something like that, from a ICE engine point of view. And then a EV is about 15 lakh average, right? A decent one. So, if you're adding another 3-4 lakhs to that, is that going to have the consumer shy away from purchasing a vehicle to grid type of solution? So vehicle to grid will happen. I think it's going to happen in a combination. It'll happen in the future. The government, as we've already talked, the government has to be a big supporter for this. The government, there has to be some teeth into biting into it and saying, yes, we want to chew now, right? And so that's the main thing for vehicle to grid. It's the technology is available, as Sushobhan has rightly said, is that technology is available. Now it's just a matter of, do we have the economics? Do the economics work out, and does the government help with the vehicle to grid type of solutions? And then, again, but I guess parallel to vehicle to grid, you have also other opportunities to augment that and supply localized energy to the house, where you have battery energy storage systems that are basically tied to that vehicle to grid. Effectively, the vehicle to grid is a glorified inverter. Okay, and so then you can use a hybrid inverter that you can get solar panel energy into that inverter. You have a mechanism where the communication in the inverter knows the ISO standard that I told you, 15118, so it understands the protocols that need to happen from the car to this. That's what needs to happen. And then you have the battery energy storage that you can do. So you have, it's definitely possible to do this, and it can happen. They're starting to do pilots now, and so then you can see I think the ISGFW. If you haven't seen it, it's a great little pilot there that they've shown that this can be done. But you see the big box. Where does that go? How does it get integrated? How much does it cost? All these factors come into play. And then do you outweigh that vehicle to grid cost with your own house consumption by doing basically this hybrid inverter that has the battery storage, that has an external battery storage, the car battery storage, and then the solar panels coming in and maybe wind energy coming in, and you're just using it internally without sending it back to the grid. So those are things that we're still studying here in India, and it's like I said, it's going to take a big leap from the entire ecosystem providing the solution.
So thank you, Paresh, very interesting. So let us continue on the V2 vehicle to grid. Pramod, how do you see that? How, as a DISCOM, you see this? It could be a very good opportunity for demand side management.
Yeah, definitely. And DISCOM already have a lot of challenges, but this time it is an opportunity. And I am very excited for this V2G because, I'll second to his opinion, my panelist opinion, that if my EV will cost 2 to 3 lakhs, how customer will be convinced that with this kind of features I should go for the vehicle with additional cost of say 15-20%. I'll give you one corollary to that. Presently, DISCOM is subsidizing air conditioners, efficient air conditioners. You surrender your old one, 10-year, 15-year-old or 5-year-old, and we'll give you 10-15% DISCOM pays to the customer, to that kitty, to change to the efficient one for the demand side management. Another case is if you surrender your old fan, which consumes 72 watt, with the BLDC fan of 22-24 watt, I'll again consume or provide the subsidy to that. So DISCOM is already into that because DISCOM has done its math that if we do this much, I'll get much more than that. Similar case is the V2G. If like same 10-15% is the number, DISCOM will be kind of in position to somehow do that, and it can make it viable. Coming back to the question, how it will help? You see, Delhi alone is going to add around 2,500 gigawatt hour of battery in the e-bus itself, which is like if you say Delhi's demand to say 10,000, 9,000 presently, maybe by next 2 years 10,000. So for 1 hour at least it is 25%, right? So 25%, and those buses will consume my 1%. So even if I harness 10% or 1% of 2,500, net circle can be met. So this is big opportunity. Number two, all these batteries will be at my load centers. It is not like in the island or in the warehouse. So the battery where they will be storing energies in the same house, I will have load. And those load, if this can be managed somehow through batteries during those peak hours, we have 2 peaks. This will be of big help to the network, and obviously to the arbitrage, like my power purchase cost is highest during those two peaks. So I see a very, rosy picture for DISCOM with through V2G, and we are ready to harness, thanks to ISGF, Delaware University and all who have involved us in this pilot, and we had very good experience in this pilot, and we are convinced that this is going to work.
So it's really happy to know that V2G is going to help DISCOMs. I'm sure maybe DISCOMs would be offering that you exchange your ICE car with the electric car, and we will fund it. So I think that could be the reality in next 2-3 years or by 2030, wherein DISCOM would be funding this. So I'll come back to again on the Deepak on regulatory and policy advocacy on vehicle to grid. So Deepak, can you just share your thoughts that how this policy and essentially required for vehicle to grid for mass adoption?
Sir, frankly speaking, I'm not much knowledgeable on that part because we are in the charging business, and V2G is it is a new concept and lot of work to be done. So on a regulatory front, actually I am not aware fully what kind of policies are coming, but like my fellow colleague Pramod is mentioning, so it is a beneficial for DISCOMs because it helps to maintain the peak load. So and in earlier session, Mr. Sinha has also mentioned the same. So I am sure there are some white papers and some working is going on, which help everyone.
So we'll continue with you on concluding remarks. So what is the one policy and what is your vision for by 2030 for India? So what immediate policy would like to get implemented? So this is for all the speakers. With this, we will conclude that what is your, number one, what is the policy you would like to get implemented in next couple of months or within a year? And how do you see what is your vision by 2030 on EV adoption and EV technology?
On the perspective of vision of our company, which is TATA Power EV Charging Solutions, so we are covering all segments, whether it is CV, PV, fleet, buses, home charging. So our vision is to enhance the public charging network and put some ultra fast chargers, or you can say megawatt chargers on the highways which cater multiple types of vehicles, whether it is e-truck, e-bus or high-end cars. And then we would like to enhance our community charging network also, because home charging is always there. When we are saying EV charging, 90% charging at home. So then we have to strengthen that part also. So that is the vision. We have to enhance our network, and right now we have like 5,000 plus chargers. So we are looking forward to have around the same number in coming few years. And on the policy front, if I say, if I seek support from government, then from all CPOs together, upstream infra is a major bottleneck on highways especially, and in cities also few areas. So if we can have any, because now the policy is there like PME drive, 2,000 crore is for upstream infra. So why not there is a policy which simply says whosoever is apply for fast charger in that city, it automatically that money goes to DISCOM, the 80% subsidy, and it helps to enhance the network quickly. That is my thought, sir.
Your thoughts, Pramod?
Thank you, sir. My thought will be like government or local municipal corporation has to come up with the kind of categorization of different area for kind of quantum of charge or charging, say per charger megawatt or kilowatt. Like if it is a locality of slum, you cannot have 240 kilowatt charger in that slum because that cannot support, that network cannot support. And if you do earlier, it is better for the DISCOM to prepare that area. So area-wise categorization of kind of load it will happen, so that policy has to be placed. Second thing is obviously on the harmonics or total harmonic distortion. So how much is going to affect, what is the tolerance limit, how it will be able, DISCOM will be able to gel that. So these two things may come up. If early it is done, better it will be.
Thank you. Regarding your vision for 2030 in EV industry, and also your one immediate policy implementation you would like to get?
So regarding 2030, if I see the roadmap, so I'll see V2G also, because right now, if you talk about the V2L, it's not alone V2G actually. It's V2L, V2H, V2V, then V2G. So V2L vehicle is already on road. So it's very simple. We can convert V2L to V2H and thereafter V2V. Okay, that is vehicle to vehicle and vehicle to home. Now V2G is having small challenges regarding the communication from the grid, and which is required the smart grid. It means grid can give a signal to EV, so or they can talk directly with the electric vehicle sitting in the home for the night charging, and in case of emergency they can ask, yes, you deliver power back to the system. So that is V2G. So V2G means alone this vehicle and the EV charger manufacturers cannot perform the task unless grid is not smart and grid is not able to communicate with the vehicle via meter. So definitely smart meters will be come into the line, into the picture, and I am not sure whether this communication will be on the wireless or on the hard wires with the PLCC. So it's completely, if I see, this is the major challenge with the grid and the distribution companies, not with the vehicle and the EV charger. And secondly, this will be there within the, I think, 4 to 5 years, but why I am saying the challenge, major challenge is from the grid side and the distribution companies, because we are talking something for a smart grid, I think minimum from past 10 to 12 years. So smart grid policies and the implementation and the working at a large scale is still not there from the government side. And maybe I will say the policy makers or large companies are not keen to do this smart grid activity in India. So the major challenge is that part. Vehicle side and the charger side, yes, it can be done easily. Slightly cost will be more for the vehicle, but I am okay if my vehicle can give the emergency supply to my home in case of emergency. And regarding this second question, regarding megawatt, so we see the example of 1 megawatt charging with the BYD car. Okay, so here again it's slightly difficult because BYD is a completely technological company. They are making blade batteries with a higher density, and those technologies are not open. Even Tesla is not able to charge with the 1 megawatt rate. So definitely BYD is not going to give this technology to any part of globe or any other companies. So it's again linked with the chemistry. Cells, whether it's a blade, lithium ion, phosphate or whatever technology. So it's, if vehicle demands, yes, megawatt charging will be in line in couple of years. Thank you.
Thank you, Jaiprakash. So your thought, Sushobhan?
Yeah, so as my presenter said that instead of V2G, we'd like to see more V2H, and as my friend also said, it is too early in India, but I'd like to, in a lighter note, so the V2H was long back in a movie, 3 Idiots, where the local hospital, there was power cut and all local batteries from the cars were used to power and deliver a baby there. So that time it was innovation, but now it is reality, right? In US, we have seen success stories of school buses feeding power to the grid from the batteries. So all innovation is initially it is better to be skeptic. At the same time, it is good to be evaluating ourselves and accepting challenges and opportunities so that it becomes reality in India as well. So I feel the present scenario in India, we are all bright minds and we welcome new innovations, new technologies in India, and it will be a success story in India as well. Thank you.
Thank you. Your thought, Paresh, quickly.
Yeah, I'll quickly just talk about the policy. The government has supported a lot of PSUs to build up the infrastructure and stuff like this, which is great. But I think now they need to move to allowing policies to have private players play a bigger role, and also allow innovation to happen within India, with a made in India, Atmanirbhar type of stuff, where the innovation is happening in India, where the government is actively looking at startups, actively looking at private players, because that's where the hub of innovation lies in that. And so, if we have more policies to foster that, besides just PSUs, because as you know, the IOCL, HPCL, and all these companies for years have had 60 kilowatt DC charger tenders out. How many have you seen installed? Right? I mean, this is not to be controversial or anything, but that policy needs to change where private players, the marquee is Tata's, right? They say something and implement it. So this is what we need to have happen, and that policies have to foster that.
So thank you very much, speakers. I think we had very electrifying session, very enriching session, and I'm really happy that all our EV ecosystem partners are well ready to take up this challenge. Thank you very much, and thank you, audience, for all your patience. In fact, because of time constraints, we may not be able to take up any questions. Maybe we can interact during the cocktail time, networking dinner. Thank you so much.
Thank you everyone for sharing insightful thoughts on vehicle to grid, vehicle to load, vehicle to home, and other megawatt charging technologies. Now I would request Mr. R.K. Singh sir to facilitate our speakers with token of mementos. Starting with Mr. Deepak Jain. Mr. Pramod Mishra. Mr. Jaiprakash Singh. Mr. Sushobhan Saha Roy. Mr. Paresh Patel. Now I would request Mr. Anand Singh to facilitate our chair and moderator for this session, R.K. Singh sir. Thank you everyone. Now I would request panel for a group photo. Thank you everyone.